Hello fellow geometers, this is Mrs. Agen and welcome to the Circle 5 video for review for this segment that we're doing on circles. You have your paper, please make sure you fill out your name. And down at the bottom, just to get us warmed up, I want you to list 8 of the vocabulary words that go along with this section. You can push pause and take a few minutes, maybe 30 seconds to a minute to write those down. And then we'll get started as soon as you get those done. Okay, welcome back. Alright, so the first page we have here has some important things to remember. Let's see, the full circle is 360 degrees, semicircle is 180, and these all, the rest of the things that you already know about, the sum of the interior angles of a triangle is 180, and so forth. We talk about quadrilaterals, intersecting lines, form congruent vertical angles, and a line can form a linear pair. So I'm not going to go over your 8 vocabulary words because we're going to come across those as we do the next section. I do, however, usually I have my students put some kind of notation around important things in their notes. This didn't come out very good, but that's okay. So when you go and look back at the sheet of paper, you'll know that this is something important that you should know. Okay, on to the next page. We have the summary chart, and here we're going to summarize the important things about the relationships between angles and their intercepted arc. And one of the first things we have to make sure we understand is what is an intercepted arc. So we're going to highlight these in yellow as we go through, and I hope that as I'm drawing these parts on these circles, you also are drawing them on your paper. So first we're going to start with the central angle, and in order to have a central angle, that means we have to know where the center of the circle is, and a central angle is an angle whose vertex is at the center of the circle. So there we have that. And I'm going to go through and I'm going to highlight the intercepted arc, which is the arc that is between the two rays or the two segments that form that particular angle. Okay, and the relationship for the arc and a central angle is that the measure of the angle is equal to the measure of the arc. So if the arc is 60 degrees, then the central angle is 60 degrees, or whatever it might be. Next we have the inscribed angle, and an inscribed angle is an angle whose vertex is on the circle, and it has an intercepted arc. And again, it's that same concept that the intercepted arc is the arc that is between the two segments that make up that angle. And it has a relationship between the angle itself and the arc. So one of the ways that we describe it is that the inscribed angle is equal to half whatever the intercepted arc is. And by applying our algebra rules here, we could also say, we could write it the other way, in that the arc is equal to twice the measure of the angle. So whichever way you want to remember that, as long as you remember it correctly, that's good. Next we have angles that are created by chords and tangents. And if you remember by the definition, a chord is a segment that has its two endpoints on the circle. And so here's a chord, and a tangent is a segment that touches the circle once and only once. That's not a very good line, but that'll do. Here's the center of the circle here. So we have 3 different circles here, so we can draw 3 different possibilities. When the center of the circle is between the chord and the tangent, or if we had a chord and a tangent, and the center of the circle is outside it, and then the special case where the chord happens to be the diameter of the circle, and it also can be just the radius tangent at the point of tangency. In either of those conditions, we still are referring to the intercepted arc. So on this figure, the intercepted arc is here. Here it's the angle formed, so the intercepted arc is going to be here. And this one, the intercepted arc, is here. And the intercepted arc is still the arc that is between the two rays of the angle or the two segments. In any event, the angle that is formed by a chord and a tangent is equal to half whatever the intercepted arc is. And that's the case. So here's the special case here. We already know that if the chord, in this picture right here, if the chord happens to be the diameter, it's going to be the semicircle, and if tangent touches at the point of tangency, half of the semicircle is half of 180, which means we have perpendicular lines there where the angle is equal to 90 degrees. Next on the list we have intersecting segments, and notice this one's special, that we're talking about if the segments intersect inside the circle. So again, here is the center of my circle, and I'm just drawing two random chords. There's one chord, there's the other chord. And I'm looking for, let's say I'm looking for this angle, angle X. And again, it has to deal with the intercepted arcs. So the intercepted arcs with respect to angle X would be this arc and this one. And when we're talking about chords that intersect inside the triangle, we know that X, the angle X, so I'm going to put it as an X this time, X is equal to, we're still talking about half of something, but this time we're going to sum the intercepted arcs. So you would have to sum those two arcs that are the intercepted arcs of both sides of those. And then last on the list we have segments, intersecting segments that intersect outside the circle. So one of those types could be if we had two tangents from a circle that intersected outside, they would form an angle. We could have a secant in a tangent that form an angle outside the circle. And we could also have two secants that intersect to form an angle outside the circle. Oops. That would be angle X. And again, we're still talking about those intercepted arcs. Let's see if I can get a little finer point here on my highlighter. It's a little thick. Okay, so we're talking about the intercepted arcs, and it is still the arcs that are between, I'm going to do the smaller ones in yellow, the smaller valued ones in yellow, and then the larger ones I'll do in green. And it's going to be, this time it's going to be the difference in those arcs, and the difference that we're going to come up with here is always going to be the positive difference. We wouldn't have a negative value there. So it's always going to be the larger minus the smaller. But nonetheless, we know that that angle X is going to be equal to half again. And this time, instead of taking the sum, we're going to have, well, I said let's do it in this. Whoops, let's get that pen. It's going to be the green arc, whatever the green arc is, and from that we're going to subtract the yellow arc. So it's the larger minus the smaller. We're going to take half of that difference. So those are the basic relationships. So if you look at the whole chart, there's only one time when it's equal to the arc. Then we have its half of the arc. Then we have its half of the sum. And then we have its half of the difference. Okay, on to the next page, where we have the bomb diddly of an example. So if you can get through this, I would say that you are ready for the quiz. So the only information we are given here is that the ratio of the arcs, DE to EA to AB to BD, and those are all arcs, is in the ratio of 1 to 3 to 5 to 3. So if you remember from your algebra skills, when we talk about ratios, that there is some common number that we would be multiplying those ratio numbers by. And they are referring to the circle, and we know that in a circle, if we made it all the way around the circle, we would have 360 degrees. So first off, we could start by coming up with an algebraic expression that 1 times some value plus 3 times some value plus 5 times some value plus 3 times some value has to equal 360 degrees, because that's going to get us the total degrees in that circle. And those arcs represent, that's like the arc addition postulate that we talked about earlier in the section. So, algebra skills, we're combining like terms. 1x plus 3x plus 5x plus 3x. We combine like terms, we get 12x is equal to 360, and we divide both sides by 12, and we see that the value of x is 30. And notice here we're talking about degrees. So x is equal to 30 degrees. So when I substitute that in on my figure, on my diagram over here, here is arc DE, and we know that it is 1x. So this is going to be 30 degrees. And if I look at arc EA, that's the second one, it's 3x. So 3 times 30, we have 90 degrees. Arc AB is the 5x. 5 times 30, we get 150 degrees. And the last arc BD is another 3x, so we know that this arc is 90 degrees. So now we have all the arcs of our circle taken care of, and now we can go further down and answer the questions. So first it says find arc DE. Well, we've done that already. We figured that out to be 30 degrees. Next, we need to find the measure of arc EA. We've done that as well. That's 90 degrees. Then we're on to arc AB. I need to slide up here a little bit. Arc AB we said was 150 degrees. And finally back to arc BD, which is another 90 degrees, and that completes our circle for the 360 degrees. Now we need to find the measure of angle A. So let's look at our picture. Angle A. What type of an angle is angle A? Well, angle A happens to be an inscribed angle. We're going to look at DAB. And so when we look at the intercepted arc for angle A, its intercept is 90. So when we go to find the measure of angle A, if we remember our formula from the other page, that the measure of an inscribed angle is equal to half the intercepted arc, and the arc that it intercepts is arc BD. Arc BD. And then we know that the measure of arc BD is 90, so we need to take half of 90, which is 45. Okay, let's take a look at, we need to find next the measure of angle B. Well, the measure of angle B is another inscribed angle, right here. So we're going to take half of its intercepted arc, and it also happens to have an arc of 90, so it's going to look pretty much just like A. We'll do it in a different color so we can see it a little differently. So the measure of angle B is going to be half of, and angle B intercepts the arc AE. So we're going to have half the arc AE. And AE is 90 as well, so half of 90, we get 45. And we need to look at arc C. Angle C. Angle C is an angle formed by outside of the circle, and so we need to look at the intercepting arcs that make that angle up. So here's angle C. So we have this arc, which is green. And the other intercepted arc that we need to use is, we need this arc. And in order to get the whole arc here, arc AED, we're going to have to apply the arc addition postulate. So if you get the total arc of AED, we're actually adding 90 plus 30. So let's go back down here. The measure of angle C, whoops, I'm still in red. Let's switch that over to black. The measure of angle C is equal to 1/2. And remember, we're taking the difference because the angle is formed outside of the circle. So it's going to be the measure of arc AD minus BD. The measure of arc AD minus BD. So that's going to be equal to 1/2. And we already said the measure of arc AD was 120 minus arc BD is 90. Let me just double check my letters here. AD, BD, yep, that's correct. Okay. We have 1/2, 90 minus 120 minus 90 is 30. And so when we take half of 30, we end up with 15 degrees. Next, we need to find the measure of angle AFE. AFE. And so that is an angle formed by two chords intersecting inside the circle. So for that one, we're going to have to use, let's go with pink. We're talking about this angle. So for that, we're going to use half of the sum of those two. So we need half of the sum of, well, those didn't come out very round, did they? Let's see what's going on here. Well, we'll leave that. Okay. Nonetheless, we have to take half of that, half of that sum. So we have half, and our one arc was 90 and 90. So half of 90 plus 90 means we need to take half of 180, which brings us back to 90 degrees. And last but not least, we need to find the measure of angle ADC. Measure of angle ADC. So that is an angle formed by a tangent and a chord. So now we're looking for, let's see what color I haven't used. Let's go with blue. So we need to take half the intercepted arc. Half the intercepted arc. This one's coming out a little better, I think, of that blue one. Yep. Okay, so let's get back to the pen. And that is, we're going to have to use the angle addition postulate there too. 150 plus 90 is 240. We're going to take half of that. So that's going to be equal to half. And I said 150 plus 90, which means we have half of 240. And half of 240 is 120. So now we found all the parts. So if you can get through this problem, if you need to redo it again, try it on a separate sheet of paper, watch the video again, and if you can get through this problem, you should be very well prepared for the quiz. Good luck, and see you tomorrow.